Determine whether a triangle can be formed with angles that have the given measures. Remember from previous lessons that it has to add up to less than 180 if we're provided with two angles, so that it leaves room for a third angle. So here I have 107 and a fourth plus 82 and a fourth. Well, 107 and 82 makes 189, and a fourth makes a half. So that's already exceeding 180. So no, a triangle cannot be formed here. The two of them combined have to be less than 180 to form a triangle. So you'll go through and you'll add together these values and determine whether they are less than 180, and if they are, then it can make a triangle. Use patty paper or some kind of tracing paper to determine which triangles are identical and explain. So I'm going to trace over these as best I can, and then we'll move them around to see if we can get them to match up with other triangles on the same section. So I've traced triangle 1, and it appears that triangle 6 might be the same. Yeah, so if I rotate it, triangle 1 and triangle 6 are the same. I might also be able to make it match up here with triangle 4. Let's see. If I reflect and then rotate it, reflect meaning flip it over. Oh, but triangle 4 looks smaller than these. So let's trace another triangle. Here I have triangle 2 traced. It looks similar to triangle 5. Yeah, if I rotate, we can get those lines to kind of line up. So triangle 2 and triangle 5. And then let's check 4 and 3. So I've traced triangle 3. If we move it over here to triangle 4, we'll have to flip it over and turn it. It looks similar, but it's a little bit larger. So it would not be identical if it's not the same size. And it does ask us to explain. So for 1 and 6 and 2 and 5, we were able to rotate our patty paper or our tracing paper and get it to line up perfectly with another triangle. For problems 2 through 6, use tools to construct a triangle. Label the given angle measures and side lengths. Construct a triangle that has a side length of 4 centimeters. So we're going to pull out our ruler, and we're using the centimeter side. So on mine I have inches and then centimeters. So I'm going to create one that is 4 centimeters long. And then it also says to label it. But then it doesn't give me any other criteria. It doesn't tell me any other angle measurements or side lengths that I need to use. So I get to kind of pick. So I'm going to use my ruler, and I'm going to connect this corner and draw a side length. And then I'm just going to connect from here to here using my ruler as well. So there's my triangle. Now we're going to continue to work on some additional triangles, but I would take a look at a triangle that you have drawn and see if it's going to come out identical to the one that I have, or if maybe you can use this 4 centimeter side length and create a different triangle from what I have, but still meeting this criteria. Here we need to construct a triangle that has an angle measure of 50, but it doesn't tell me any information about how long the side lengths need to be. So I'm just going to use my straight edge to draw a side length. It does not matter how long. And then I'm going to pull out my protractor. And I'm going to create an angle that is 50 degrees. So I will line it up on the line and the end point there. And then I will create my mark at 50 using a straight edge or a ruler. You're going to connect this dot to that dot. Then we're going to connect our point from here to here. So don't forget to label your angle. Oops. Of 50 degrees. And then connect from here to there. Now I could have extended this line beyond that dot, and it would still be a 50-degree angle. So it could continue out here, and my side length could match up higher, creating a different triangle that still meets this criteria. Construct a triangle that has a side length of 1.5 inches and a side length of 2 inches. So using the inch side of my ruler, I need a side length that is 1.5. And then I also need a side length that is 2 inches. And then I need to connect them. Construct a triangle that has an angle measure of 48 and an angle measure of 92. I'm going to start with just a side length so that I have a spot to build my angles off of. Using my protractor, I'm going to create this angle on the left side to be 48 degrees. So I'll line up my protractor on the left end point, and I will create a mark at 48. This would be 45, so 48 is right in here. Then using a straight edge, I'm going to connect from here to there and label it 48. Then from the right hand side, this time I need an angle that's 92. So we're starting on the left, moving towards the right. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 2 little marks. And we'll create a line from here to there. Now this is just extra, so I can erase this piece here, making my line smaller. But make sure that you label that this is 92 degrees here, and then the triangle piece is this section there. Construct a triangle that has a side length of 4.5 centimeters and an angle that measures 84. So I'll need my ruler and my protractor on this one. So we'll start with a 4.5 centimeter measurement. and then we need an 84 degree angle. Now, depending on whether you choose the left or the right, it might look different, but you can use an 84 angle from either side. So we're going to line that up. You've got 10, 20, 30, 40, 50, 60, 70, 80, and then we need a little 4. We'll connect from here to there using a straight edge. Don't forget to label this angle. Now, depending on where you draw your line, it could go here, 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 or here. So this angle in the bottom corner is still 84, but we can change this side length depending on where we connect it. So we can erase this piece here so that it's just the triangle that's left. So here we see that they've used that same criteria of 4.5 centimeters and 84 degrees. This says that the side length is adjacent to the angle, meaning next to. So here's the side length and here's the angle, and they're next to each other. And this one shows the side length is opposite or across from the angle. So something that's similar about them is they use the same measurements, but they are not the same triangle. If we tried to trace this triangle and move our tracing paper over, we would see that these two triangles are not identical. So using just one angle and one side length is not enough to guarantee that we will get the same triangle. This says on construction paper, use tools to construct a triangle with the same angle measures as the first triangle. Label the angle measures, then cut out the triangle. Since 2 criteria was not enough to guarantee identical triangles, there's 2, there's 2, there's 2, and here we only had 1, do you think that 3 criteria will be enough to create identical triangles? We're going to create a triangle using 3 of the same angles and then do the same thing again, but with those same angles, but we're going to cut it out and see if they are identical triangles. So this time we're using 3 criteria, and the 3 criteria are the angles. So the 3 angles in a triangle have to add up to 180. So let's do an angle that's 100 degrees, an angle that is 30 degrees, and an angle that is 50 degrees. Because 100 plus 30 is 130, plus 50 makes 150. So we're going to start here using a side length. Any side length will do. Then with our protractor, we're going to measure a 100 degree angle from one side and a 30 degree angle from the other. So here we've got a mark at 100. We'll connect those using a straight edge. Don't forget to label that that's 100 degrees. And then we're going to create a mark at 30. So here we have 10, 20, 30. We'll connect these using a straight edge. Label that with 30. And then this angle up here has to be 50. Now we're going to create a second triangle. This time let's put 30 over here. And we'll connect those using a straight edge. And we'll put 50 over here. And connect these using a straight edge. Now that we have both, we're going to trace. I'm going to trace using a highlighter so that way we can see the underneath piece. Actually, let's just move the whole triangle. If I were to rotate to line up my 50-degree angle and my 30-degree angle, you can see that they are, very similar, but they're not exactly the same size. And if I were to repeat this process again, I could make this side length across the bottom even longer, and I could do my 50-degree angle from here and connect. And then I would also need to extend this side length out, still lining up with that dot for the 30-degree angle. And my triangle is significantly larger than the one from before, even though my angles all match up, even though I have 3 criteria. So just having 3 criteria, even that isn't enough to make our triangles identical. We need to be specific about those 3 criteria. 3 angles is not going to create identical triangles. In your book, on page 95, there's a graphic organizer, and it says how many triangles. So no triangle, 1 triangle, or more than 1 triangle. You're going to think back on the previous few pages. When could we create 1 triangle? When could we create multiple triangles from the same criteria? And when could we create no triangles? Well, we weren't able to create a triangle if the sum of the 2 small sides was not greater than the largest side. And in our warm-up from today, we also saw that we weren't able to create a triangle if the sum of the angles was more than 180. We were able to create more than 1 triangle when we were given 1 angle, two angles that were less than 180, or 3 angles. We were also able to create more than 1 triangle when we had just 1 side length provided. Back here in problems 4, 5, and 6, we had 2 side lengths, 2 angles, and a side length and an angle. Can you think of any other situations where we could create more than 1, or where we would get exactly 1 possible outcome? Add those to your graphic organizer. That's the end of lesson 6. Please check back for lesson 7, coming soon.